This is going to be fast and furious. Okay, theoretical and experimental probability. Do not read that to me. I can read it. Tell me what you think theoretical probability is. Ooh, what do you think?
Yes.
Okay, you guess? What else? Anyone? Thought? What?
Easy word. Like it's kind of easy. You guessing?
What do you think it is? What do you think when you hear the word theoretical?
Yes.
What immediately comes to mind?
Theo.
A theory.
Theory. Isn't a theory like a guess? Yeah.
A theory, yes, it's like a guess. Okay, so what do you think when you hear the word experimental?
Experiment.
You're experimenting. Okay, so with math and probability, theoretical probability is what should happen. Okay, that's what should happen. The experimental probability is what did happen. Okay, so we're going to look at this experiment 1 here, and I just want y'all to kind of follow along with me. Amanda used a standard deck of 52 cards and selected a card at random. She recorded the suit of the cards she picked, then replaced the card. The results are in the table below. So before you start writing and figuring out, let's just look at it. Diamonds, hearts, spades, clubs. Those are the suits, right? You all know about cards, yes? So this says, what is the theoretical probability of selecting a heart? Well, how many different suits are there?
4.
4. How many of them are the heart?
1.
1. So theoretically, it's 1 out of 4. That's what you should pick. Okay? Are you with me?
That's easy.
It is easy. And then number 2 says, based on her results, what is the experimental probability of selecting a heart? Well, this is her experiment, right?
Yeah.
How many times did she pick a heart? 9 out of how many?
4.
52. She picked it 9 out of 52. Yes, sir.
How did you get 1 out of 4?
Because there's 4 suits. It would actually, let me make it a little different, okay? Don't erase yours. There are 4 suits and there are 13 of each out of 52 cards, okay?
Did you add a catalog?
Which simplifies to 1 out of 4. But I just simplified it right here because there are 4 suits and only one of them is a heart.
So it's 13.
That's probably confused you. I got 1 out of 4 because there are 4 suits
I get that part.
and 1 is a heart. But this is the actual experiment
How did you get 13?
because there are 13 hearts in a deck of cards. There are 13 diamonds in a deck of cards. There are 13 spades and 13 clubs. If you simplify 13 over 52, you get 1/4. You with me? That's it. So look, what does number 3 say?
Number 3 says, with the theoretical probability of selecting a diamond or a spade.
So theoretical for diamonds and spades. How many suits are there? 4. How many are diamonds and spades? 2. 2 out of 4 simplifies to what?
1/2.
1/2. And then the experimental probability would be diamonds are 7 and spades are 11. So that'd be 7 plus 11 is
18.
18 out of
18 out of
52.
There you go.
52.
Yeah, it's pretty simple. So we're going to skip the whole next page and we're going to go to this page number 3. A number cube is rolled and the results are in the table below. So if you look here, the number cube, it has 6 sides on it, right? And this is the experiment. This is how many times you actually landed on the 1, the 2, the 3, the 4, the 5, and 6. Okay? So theoretical, then the even number we rolled would be, how many even numbers are there?
3.
3 out of
6.
6, which simplifies to what?
1/2.
3, 1/2, right there. Okay? So theoretical would be 1/2. Look at number 2. If you roll a number cube 36 times, how many times did you expect to roll a number 1? This is more theoretical. How many ones are on a cube? 1 out of 6, and this is where our favorite comes in. Proportion. If 1 out of 6, how many out of 36.
6.
6.
6 math.
I need to get the rate.
6 times 6 equals 36. Easy math.
Good? Look at number 4. What is the theoretical probability of rolling a number greater than 4? Well, how many numbers are there on the cube?
6.
6. And how many of them are higher than 4?
2.
2. And that simplifies to,
Wait, no, 130.
pretty simple, right?
Good job. It's not-
So now we're going to look at the experimental probability of rolling a number greater than 4. So how many times did they roll the die? You gotta
Six.
add, no, you gotta add these up. 8 and 3 is
8 and 3 is 11.
11 plus 9,
20.
20,
26.
26, 36. So we added those up and got 36. So the experimental probability of rolling a number greater than 4, they rolled it 36 times, and how many times did they land on greater than 4? 10. Does everybody see where the 10 comes from?
Yes, ma'am.
4 plus 6.
Oh, yeah.
There's a 5 and a 6, 4 and 6 is 10.
Well, we
And
got
then you
about
would simplify that to
5 over
13.
okay? It's all just more probability. I know I'm kind of going fast, but we're going to scooch on. Look at the practice here. Look at number 1. Stop asking me every day if we have homework. Number 1. If a car factory checks 360 cars and 8 of them have defects, how many will have defects out of 1,260? Probability and proportion. I'm going to put defects over cars and write a proportion. 360 cars and how many have defects?
8.
8. 8 defects out of how many?
360.
It wants to know how many defects out of,
2. 1.
stop, I mean, you
I mean,
don't,
1,000. That's 1,060.
1,260. Do you know how to solve that?
yes.
You can do that on your own. Look at number 2. If a car factory checks 320 cars and 12 of them have defects, how many out of 560, we're going to mark out the word not, will not have defects? I mean, will have defects. You're going to do the same thing. Okay? A lot of these go back to yesterday. Look at number 3. You plant 30 African violet seeds and 9 of them sprout. Use experimental probability to predict how many will sprout if you plant 20 seeds. Well, 9 out of how many sprouted?
30.
If 9 out of 30 sprouted, the question is how many out of 20? Where does the 20 go?
Bottom.
Do you know how to solve that?
Yes, ma'am.
Yes, you do. Number 4 is like yesterday. I believe number 5 and 6 are like yesterday. There are 13 of these, and you are going to do them all. It will be due when you come in tomorrow.
Yes, ma'am.
I will expect it to be done. If you need help, don't come see me in class, because that was fast and furious.
Yes, ma'am.
That's what he there.
Oh, so close to solving number 1.